Can you go even further? This problem was proposed by Brainwave 172 in chat, right? Um, yeah. First of all, there's this integral of square root tan x by sine 2x dx, which turns out to be square root tan x, and now we have to introduce square root tan x, what that could be. This integral involves a lot of algebra, and let's say. Also, I think it's interesting to prove the first integral as well, right? Because that also looks pretty cool. And after that, we'll go to second integral. The square root of tan x divided by sine 2x dx. So you can guess from the answer what sort of u substitution you should make, right? So if you just make u substitution as u equals to square root tan x, then your answer is gonna be u. So that's what we do. And if you do that, you will find u square is equals to tan x. You get 2u. Du is equals to sec square x dx, right? And from there, 2u du by sec square x is equals to dx, right? Now you can substitute dx as the given value. Now square root tan x is just u, sine 2x is just sine 2x, and then dx is just 2u du by sec square x, right? Now you can break the sine 2x, which gives you 2u square. This is 2 sine x cos x, and sec square x is 1 by cos square x, and then du, right? Now this will become 2u square by this will be 2 tan x, right? Du. 2 cancels out. We know since u is root tan x is just u square, right? So u square by u square du. This cancels out, and then integral of du is equals to u plus c, right? And our u is square root tan x. So this is square root tan x plus c. This was pretty expected, right? Yeah, so let's go to the next integral, which is the major goal of this video. And then this, while solving this, you will come to a new realization that you can use in your further integration journey. You will basically get a realization that you can actually factorize this expression. So that will be a new thing for you. Yeah. Okay. So let's try to solve this integral now. We first will try to translate this to just all like algebraic terms, without these trigonometric terms. So for that, if you make a substitution that u is root tan x, you will get y square is equals to tan x, and the x is equals to tan inverse y, right? And then dx will be equals to, sorry, this is y square, right? And then dx will be equals to 1 by 1 plus y to the power 4 times 2y dy, right? So that gives us dx is equals to 2y by 1 plus y to the power 4 dy. Now, if we just make the substitution, or dx as this thing, and also y is root tan x, we get y, and dx as 2y by 1 plus y to the power 4 dy, right? So this gives us 2y square by 1 plus y to the power 4 dy, right? This integral looks pretty easy, but needs a fair amount of calculations. Okay, so let's see. So I told you that we will try to factorize this expression 1 plus y to the power 4 and then use integration by parts, and then it will be simple, right? So how do you factorize? So here's the way. To factorize it, you basically introduce 2y square to complete the square, and also introduce negative 2y square, right? After that, this becomes 2 times integral of y square. Now this is 1 plus y square whole square minus root 2y whole square dy, right? After this, this will simplify to y square, and then 1 minus root 2y plus y square, 1 plus root 2y plus y square, right? Now how do you break this into partial fractions? I forgot to over here. Okay. How do you break this to partial fractions? Okay, let me show you a simple thing that will actually help us to break this to partial fraction. So 1 minus root 2y plus y square. 1 plus root 2y plus y square. So we need to break this as some x plus b, right? Let me not write anything actually. Some x plus b divided by 1 minus root 2y plus y square, and some cy plus d times 1 plus root 2y plus y square. Okay, notice one thing. So let's say if here it's 1 and here it's negative 1, what's going to happen? These two will multiply to give 1 plus y to the power 4, right? In the numerator, this will just have 1 plus root 2y plus y square. And over here, that will be negative 1 plus root 2 y plus y square. Am I doing it right? Yeah. So in this scenario, there's a negative y square. Okay, in this scenario, what's going to happen? Like, we will just have root 2y by 1 plus y to the power 4. Is that correct? Sorry, 2 root 2y, right? Okay, now here we need y square. So let's say if we make this y and negative y, now what will happen? All this term will be y square, y cube, negative y square, y cube, right? Again, this y cube will cancel, y negative y will cancel. So we have 2 root 2 y square, right? So now let's say if I put 1 by 2 root 2 over here, now what will happen? I will just have y square, right? So that means this is the correct way to break into partial fractions. You see? This is the correct way to break into partial fractions because we exactly get to what we want, right? Okay. So then let's break into partial fractions. 2. And then we see that we need to have 1 by 2 root 2 over here in denominator. And then y by 1 minus square root 2y plus y square, right? And then minus y by 1 plus square root 2y over y square. That's a lot of progress. Yeah. Okay, now let's see how we should proceed ahead. Before I go ahead, let me just make sure there are no problems, right? Because if there are, okay, I don't think there's any problem. Okay. Now let's complete the square, and then, yeah, so this is 1 by root 2. Y by, this will be y square minus 2ab, right? I'm just completing the square. Also, I have to make sure that this is root 2y plus b square is 1 by 2, and there's 1, so again another 1 by 2 is needed, right, to make sure that we don't really change the expression. This is y square minus 2y 1 by root 2 plus b square plus half, right, and then dy. So now this is just 1 by root 2 integral of y by y minus 1 by root 2 square plus 1 by root 2 square, right, minus y by y minus 1 by root 2 square plus 1 by root 2 square, right, and then dy. Okay, now how do we proceed? Now, I think we definitely need to make a little bit of more simplification because we cannot just integrate like this. So what I'm going to do is, integral of, I should introduce y minus 1 by root 2 plus 1 by root 2 over here. You will see y, maybe you already saw y, but yeah. And over there, this will be y. Oh wait, how did both sides have y minus 1 by root 2? This should be having plus, right? And okay, y plus 1 by root 2 and then minus 1 by root 2, right? So this is y plus 1 by root 2 square plus 1 by root 2 square dy, right? Okay, so now this is 1 by root 2 integral of. So now I will just try to break this integrals in simpler form. So y minus 1 by root 2, y minus 1 by root 2 plus 1 by root 2 square minus y plus 1 by root 2, y plus 1 by root 2 square plus 1 plus root 2 square, right? And then again, the integral continues. So over here, plus 1 by root 2, right? Notice that this is outside all, that 1 by root 2 is outside all. Yeah? Uh, yeah, 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 yeah. Okay. And 1 by root 2, but y minus 1 by root 2 square plus 1 by root 2 square, right? And then minus minus this becomes plus over here. So 1 by root 2 y plus 1 by root 2 square plus 1 by root 2 square, and then dy, right? Now, this becomes 1 by root 2 outside. And okay, so if the denominator is just z, this numerator is just dz by 2, right? So that's why if I give 1 by 2 over here, then this 2 times this expression in numerator will just become the derivative of denominator. Am I right? Yeah. So then 1 by 2 log of y minus 1 by root 2 square plus 1 by root 2 square. And then minus 1 by 2 log of y plus 1 by root 2 square plus 1 by root 2 square, right? And then now plus 1 by root 2, now this becomes 1 by a tan inverse x by a, right? So 1 by a tan inverse x by a, that will become root 2y minus 1 by 1. Again the same thing, 1 by a tan inverse x by a, root 2y plus 1 by 1, which is just nothing. Okay, and then plus c. So now this root to root cancels out, root to root cancels out, and this finally becomes 1 by 2 root 2 ln of y minus 1 by root 2 square plus 1 by 2 minus 1 by 2 root 2 ln of y plus 1 by root 2 square plus 1 by 2, and then plus tan inverse root 2y minus 1, and then this also becomes plus tan inverse root 2y plus 1 plus c. That was a lot of work. Yeah. But we did it. Now we just need to substitute y as the square root of tan x, and you can do it yourself, right? Now, now just substitute y as the square root of tan x, and that's our answer. But before I end the video, I'm gonna give you something more. I'm gonna give you something really, really nice. But let's just summarize this before I give you the really good idea. First of all, we made a u substitution, and then it reduced the algebraic problem, and then we factorized 1 to the power 4. And then, yeah, the partial fraction was just made by observation rather than going rigorously. I mean, rather than using the analysis, And then, yeah, there was 2 root 2, 1 by root 2 over there. And then we completed the square. And then we made some changes in numerator so as to simplify the integral, so as to make the integral solvable, right? And then it was just some well-known integrals. And that solved the problem, right? Oh, wait, I forgot something. Okay, I forgot to multiply this third and fourth term by 1 by root 2 actually. If I do that, here will be 1 by root 2, right? And here will also be 1 by root 2. Okay, yeah, I actually forgot to distribute 1 by root 2 to third and fourth terms. I think now it's perfectly correct. If there are any other minor errors, maybe you can let us know in the chats, right? Okay. So let me show you something else that I wanted to show you. Also, this integral of sine to the power ax cos to the power bx dx. Okay, let me give you a general formula for this one, which is and how this formula helps us solve this integral is because integral of square root tan x dx. This can be written as integral of sine of half x cos of negative half x dx, right? So basically solving this is equivalent to solving this one, because then we can substitute a as half, b as negative half, right? So the general formula is sine of a plus 1 x cos of b minus 1 x, and then modulus of cos x to the power 1 minus b. I don't know where this modulus comes from. And then 2f1, this is a simple hypersymmetric function, and its inputs are a plus 1 by 2, 1 minus b by 2, a plus 3 by 2, colon size sine square x. I will define hypersymmetric function, don't worry. All divided by a plus 1 plus the constant. And to define the simple hypersymmetric function, it's defined as 2f1 a b c semicolon c. This is defined as sum from n equals to 0 to infinity of Polylogarithm symbol for a, Polylogarithm symbol for Pokemon. I don't know if it's Pokemon or Polylogarithm symbol for c, and then z to the power n by n factorial. Or again, this Polylogarithm symbol q sub n, let's say, is defined as q plus 1, q plus 2, up to q plus n minus 1. And this is actually equal to gamma of q plus n by gamma of q for all n greater than equals to 1, and Polylogarithm symbol of 0 is defined to be 1. Okay guys, so yeah, this is a pretty good formula, and you can also solve it in this formula directly, right? But like this is not really a lot helpful, because this is just, I mean, it's helpful, but sometimes it's just like noticing. Okay, so now we are done with this video. I hope you enjoyed this cool formulas, facts, and everything. And you can definitely recommend problems, but I'm not sure they're good at solving a lot of problems. So if you want, you can also give me a solution, or if it's easy, I'll do it on my own, right? And yeah, I look forward to seeing you in the upcoming videos.